These are just some of the steps a PCB manufacturer factory has to pass through to make professional and high quality PCBs in less than 1 day since the order was placed. So I want to pass through each of the steps with real examples of PCBs that I've designed and ordered from each step of the process: drilling, exposure, creating the mask, creating the tracks, the solder mask, the solder paste, the silk layer, cutting the board, and so on. So using these examples, I want to explain to you why each of the steps is so important in order to get high quality standards for the PCB. And with that, we'll learn how nowadays the PCBs are made and why the prices are getting so low. It's incredible. With pcbway you can get 5 or 10 PCBs like this one for only $5. So guys, let's go through each of these steps and explain you in each process what is made and how it's made. That being said, let's get started. What's up my friends, welcome back. So let's just start with the beginning. I want to make my own Arduino Uno board, one like this one. So I've made my own design and then order it at pcbway as always. But you see, I didn't order only the finished PCB. I've also tried to order some of the main steps of the production of the PCB, as you can see here, from just the plain copper board to the finished PCB. Now I didn't order all the 20 or more steps that we have in the PCB production because that would be crazy, but I do have the main ones, and you will see how easy it is to understand the entire process using real examples. Okay, so first of all we need a design for our PCB. And this will be step 0, not step 1 of the production, because this is not the job of the PCB manufacturer. Because this is your job. We have to make sure that we have a good design. Now, yes, when you send the files to the factory, the PCBway engineers will take a look and make sure that the files are okay to be printed on circuit boards, on copper boards. So they will check if you had good clearance, if the pads are too close to each other, or if you have any kind of error. They will get in contact with you, you can change the error and then make sure that the file, the finished file, will be okay to be printed on circuit boards, on PCBs. Now for any PCB designing software, when you export the files for PCB production, which are called Gerbers, you'll be able to select the layers that you want to export. And because the PCB production is divided into layers. Now we do have a bunch of layers, but these will be the main ones. The top layer copper and the bottom layer copper. And these are the tracks of your circuit. This is the actual design of your PCB, made out of copper. Then we have another layer which will be the drill. And this represents all the holes of your PCB, for the vias, for the pads, and so on. Then we have the solder mask layer, and this represents all the areas of the PCB that should not be exposed, and also all the areas of the PCB which we could then solder with any kind of soldering iron. Then we have the silk layer, which is just an overlayer above the solder mask with a different color, just marking the components, the values, even logo if you want, and this has no technical use, it's just for visual effects, in order to see components. And finally we have the layer of the board outline, and this layer will tell the machine how to cut it, the final shape of the board. Now we could also have some extra layers, for example we also have the solder paste layers, or maybe the layers in between the PCBs, but anyway we'll talk about those in just a few moments. But if you get all these layers that we have talked about and you sandwich them together, you get the final PCB. And that's what we'll see today. Okay, so now that we know all the layers and we have all these files into a folder, we send these files to pcbway to create our PCB. Now any PCB will start with a plain copper board. And in this example we are talking about a 2-layer PCB, so we have the top side, the bottom side, so we have no layers in between. Because that will be a multi-layer PCB. And this is crazy because PCBway could go up to 14 layers. So you would have 14 layers in between the top and the bottom layer. That's crazy, right? Anyway, for this video we'll talk about just a 2-layer PCB, one like this one. Okay, so step number 1 for the PCB production is the file inspection and the pre-production. In this step, an engineer from PCBway will receive your files and check if those are okay or not for the machines. And remember, you should set something like this: a file for each of the layers that will later go to the machine. So if this passes the terms of the factory, you're good to go, and they will pass those to the machines and the process will start. Okay, then we get to step 2, which is to prepare the boards for manufacturing. Now usually each factory receives the copper boards in a very big format, too huge for the machines. So in order to work a lot easier with the machines, they cut first the boards to size, let's say 800 by 800 millimeters. In this case, for this example, I will use 100 by 100 because for me it will be a lot more difficult to work with 800 by 800. But anyway, the first step is to cut the board to size and clean it. Now the most common used board is fiberglass covered with copper, but it could also be the base of aluminum or even plain copper. Now in this case, for example, I have this other PCB which instead of fiberglass has a base of aluminum, because for this project I wanted this PCB to transfer the heat a lot faster. So you can select those on pcbway when you order the PCB and select fiberglass, which is FR4. You can select aluminum, copper, or any other material that they have on the website. But you should know that the most common use and mass produced is FR4 or fiberglass. And fiberglass is a dielectric, meaning that it won't conduct electricity between the layers, so it will act as an insulator. During this step 2, they also bake the boards. So in this way they remove any organic and moisture from the board, because it's very important to clean the board and not have any contamination on top of it during each of the steps. So for example, here I have a board that was left outside and also with a lot of moisture. As you can see, the color change is a lot more oxidized, and here I have a board that is brand new and also clean with alcohol. So it's very important to clean the board from any residue and also protect it from moisture. Okay, so by now we have this. A board cut to size. This is just plain copper, and also what it was baked, cleaned from organic residue and any moisture. This is the second step. Okay, so for the third step, because this is a 2-layer PCB example that we'll talk about, we skip the step 3, 4, 5, and 6 because those are for multi-layer PCBs. So they create the layers in betweens and then they make the lamination. So we will skip that. So in our case, the third step will be the drilling process. Drilling must be made before we make the tracks, because otherwise imagine that you have very fine tracks of 0.2 millimeters. If you make the drilling process after you make the tracks, the probability of you breaking those tracks with the drilling process is very high. So first we make the drills and then we make the tracks of the copper. So the third step is just to make all the holes of your PCB. The small vias, the big ones, the big holes, all the holes are made in the drilling process. So during this process, they place a wood board first, then your PCB, and they also cover it with an aluminum plate, because in that way they protect the copper while drilling and also they help dissipating the heat. So both the drills and your copper will withstand a lot more friction, so in that way it's a lot more protected. They also add 4 pins on the corners of the PCB to make sure that the layers won't shift and you get always the same position for the holes. So using different sizes for the drills, they make all the holes of your PCB, and once that process is finished, they remove the layer of the aluminum and they inspect the PCB, and if everything is good, you end up with this. So this is still not protected. We have the drills, but the copper is still exposed and we don't have the tracks. But basically on step 3 we pass from this, which is just a plain copper board, to this, which is the same board but with all the drills from your files. Okay, so now we pass to the fourth step, which is called electroless copper deposition. Because you see, when we make holes into a copper PCB, we don't have a connection between the top layer and the bottom layer. But the tracks, the vias, that's what they are for. Because with the via we have a connection between the top layer and the bottom layer, so the circuit can continue on the bottom side. So how do they make that connection for the holes between the top side and the bottom side? Well, using this first step, which is called electroless plate process, which is basically filling the holes with a material which is conductive, and they need this material to be conductive for the next process, which is step 5. Okay, so for the step number 5, now we have our holes filled with that paste, which is conductive. And now we pass to this step, which is called electroplating. And it has the electro word in it because they use electricity to do that. Basically, they submerge the PCBs with that conductive paste in the holes, in a solution, in a chemical solution that has copper in it. They connect electricity to the board, which is conductive now. They also connect electricity to the water, and using this electricity, the copper from the solution will deposit on top of the holes, layer by layer, creating a uniform copper layer inside of the holes. So now we have a good connection between the top plane and the bottom plane. So you will end up with something like this, which is basically the same PCB as before. You can see the difference because now we have the copper inside of the holes. So it's the same PCB but with copper inside of it. Okay, so now we get to step number 6. And as you can see, I have 4 PCBs here for the example. This is the original one from step number 5, which are the drills and the copper filled holes. But then we have these 3. Now on this step, on step number 6, we create the mask of our circuit because we want to create the tracks of the copper tracks of our PCB. This will be the end goal. So in this step, number 6, the engineer will take your design for the copper. Let's say that we start with the top layer. They take that layer and will create some sort of mask, something like this that you can see on the screen. And then they take the original PCB from step 5 and fill it with a photoresistive resin or paint. In this case it's black, but it could be any other color. The important part of this resin is that it will solidify under UV light. So in between the UV light and the PCB, they add the mask with the shape of your circuit. So basically now the light that will touch the PCB will have the shape of your circuit. So only the parts that are not covered by this mask will solidify, basically creating some sort of pattern on your PCB made out of this resin. Once they added the mask and solidified the tracks of your PCB, they take this PCB and clean it with some sort of solution, maybe alcohol, that will remove only the resin that is not solidified. So basically we'll get a clean board, but you will also see the tracks made out of resin, something like this. As you can see, it's the same as on step number 5, but now we have some sort of dark areas which represents the resin that is on top of the copper tracks. So why do we do that? Well, let's prepare for step number 7. Okay, so for the step number 7, they take this PCB, which now is clean except the tracks which are still covered with that resin, and this step is called etching. So basically they submerge this in some sort of acid, depends on the technology, but the main idea is that acid will only attack the copper. Now, because the entire PCB is exposed except the tracks, it will start eating or dissolving the copper from the entire PCB except the copper that is below the resin, the photosensitive resin that we have added on step number 7. And that will end up in something like this. As you can see, all the copper was removed, but we still have our tracks. And once we have our tracks, we can clean the solidified resin with some sort of alcohol or a different solution, and we get this. And this is already our circuit. Now this is not yet ready because the copper is still exposed, so we have a bunch of more steps to make, but we have our design. We have the holes, we have the copper, and we have the shape of the tracks. Now the step number 8 is just for inspection. They take your file, the CAD, which is just like a picture, and then they take pictures of the real circuit and inspect it, just to check if you have some loose tracks or maybe some short circuits or any kind of error. With very fast machines, they take a picture and analyze that, and if everything is okay, we can go to the next step. But if something is wrong, they will discard that PCB or even start over the process if something got in between the machine and the PCB. So yeah, that is step 8. Okay, so we are now on step number 9. Now we have our tracks, but you see, we still have problems. Because copper is a very good conductor, it conducts electricity very well, but it has its downsides. For example, the copper will oxidize very easy. Just leave a copper board outside with moisture and it will turn like dark red or even green sometimes, because that's the oxide that it creates with carbon dioxide. Anyway, it will get damaged pretty fast. So we need to cover this copper with a different material, and that will be step number 9, which is called surface finish. Basically, we make yet another electroplating with a material that will stick only to the copper. So we dip this yet into a different solution, and that solution could be for tin and lead, it could be for gold or hard gold. If you go on pcbway.com, when you order the PCB, you can see that you can select from different surface finishes. From tin and lead, which is the most common, which is this one here, it's how the PCB will end up. But you could also select gold or hard gold or any other material that you can see on that list, depending on the PCB that you want to make. For example, for good contact conductivity, we use gold finish, as this PCB here. For example, we have this pads for an SD card, and since they have a gold finish, they have a good contact conductivity. Also, gold will not get oxidized that easy as copper, for example. So this has a gold finish, but in this case, for example, this other PCB has a lead and tin combination of surface finish, which works quite good. This is the most common use. So we add a finish. So we go from this, which is our circuit in copper, to this, which is basically, as you can see, the same circuit, but with some tin and lead on top of it. And this will withstand for a lot more time. And not just that, it won't get oxidized, and it's also a lot harder than just plain copper. So, can you see the difference? This is just copper and this is tin and lead. So now we have our circuit covered and protected so it won't get oxidized, but this is still unprotected because yes, it won't get oxidized, but I can still touch it, maybe make a short circuit while soldering, or maybe just touch it with a screwdriver and peel it off. So we still need to make one more step to cover it. And that is step number 10, which is called to add a solder mask on top of this. You see, when you order the PCBs, they never arrive like this. you usually are not able to see the fiberglass. They always have some sort of color. The green one is the most common one, is mass produced, but you can have any other color. If you go on pcbway.com, you can see that you can select from green, blue, orange, even pink color for your PCB if you want. So basically they will add the color of the solder mask depending on your settings that you can select. And this process, step number 10, is called solder mask. And this is very important. So this step is similar to step number 6 because we also create masks. So basically, obviously, the first thing is to just clean the PCB. You have your finished PCB, you have to eliminate any residue, clean it with some sort of solutions, and get the same PCB but very, very clean. And then they add this resin, which is called solder mask, and this could be in different colors. As you can see here, I have some examples. I have the green one, this is white, red, blue, even a black one. So they add that, which is kind of liquid. As you can see, you will end up with this. They add a very fine coat. This is not perfect. In the factory, they will do it perfect. This is a homemade version. So they add that, and this once again is also photosensitive. So it will get hard, it will harden under UV light. So once again, the engineer will get the design of your file for the solder mask, will place it between the PCB and the UV light, and only the parts that are touched by that light will harden. Then they get the PCB under UV light and then submerge it once again into a solution that will dissolve the resin that is not cured. So you'll end up with this. It's the same PCB, but now everything is covered in the solder mask except the parts that you don't want. Usually are the parts for the pads and the connections where you want to get and solder parts to it. So now you can just touch the PCB and you won't get electrocuted because this is insulated, and also the entire PCB that is below is well protected. Now in some cases you expressly go into the design and select the parts that you want to remove from the solder mask. For example, all these parts here, all these tracks, I've went into the design and selected that I don't want these tracks to be covered because I want to fill this with some extra solder to withstand more current. But usually all the parts that are not pads or parts that you want to solder are covered by the solder mask, so you have to expressly go into the design and select which parts you don't, in case that you don't want. So now we pass from this to this. The same PCB, but now this is a lot more protected. And now we can get to the next step. Now in between, obviously we have a bunch of other steps like cleaning, removing this, removing that, which are not that important. But for now, before we go to the next step, we know that we have passed from plain copper board cut to size. Step number 3 was to drill the holes for the PCB. Then we cover the PCB in a photoresistive paint or resin, and using a mask and UV light, we create the mask of our circuit on top of the copper. Then we submerge this into acid, remove all the copper except of our tracks. So we get our circuit, both on the top side and the bottom side. This is not yet protected, so then we cover it with the step number 6, I think it was, or 7, which is the surface finish, where we cover the entire copper with a different finish. In this case is lead and tin. This is still yet not protected, so then we cover once again the PCB in a different resin for the solder mask, once again with UV light and the mask. We create the mask for our circuit and the pads, remove the rest of the resin which is not cured, and we get this. This is the final circuit, and this should work, but it's still yet not a finished PCB. So let's see what other steps we have in order to get our professional PCB for the Arduino Uno in this case. Okay, so we get to step 11, which is to print the silk layer. So we pass from this, which only has the solder mask, to this one, which also has the silk layer, both for the front side and the back side. As you can see, I have my logo. Now this layer is not important for the usage of the PCB, for the work of the PCB, but it's important for us, for the person who is assembling the PCB and for the final customer. Because in this way you can see all the components, the values, the names. So if you have a schematic, you can relate the values on the schematic with the values on the components of the PCB. And you can also add your brand, your name, and which is the output, the input, and so on. So it's not important for that, but it's important for this, for the final usage of the PCB. Now the color of the silk layer usually is white for the green solder mask, for the red one, for the black one. But obviously if you select a white solder mask, the silk layer will be black. And if you go on pcbway.com, you can select the color of the silk layer depending on the color that you want. So you can just go into the settings, select that, and when they are making your PCB, they will add the color that you want. So basically we go from this to this. As you can see all the components, and on the back you can see electrodes.com and also my logo. Pretty nice, right? And now we can pass to the next layer. And finally, step number 12 is to cut the board to size, because this would represent the big board in the factory, which will be 800 by 800 or even bigger. But then the engineers will take the file of the outline of the board, they send that to the machine, which will use rotary engravers and cutters, and cut the board to the final size. And also during these steps they can also make the V-scoring, which is basically just make a mark where you want to snap the PCB, or maybe you have some vias and you want to break it there, or maybe panelize the PCB and they cut only the outline of the panel, and then you will be able to cut your panel at home with the V-scoring. So they do all those processes and finally they cut it to size. And as you can see, we pass from this, and on the back side we have a lot of white for the silk layer. We pass to our PCB, and as you can see, we only have the shape of our PCB and the silk layer that we want. And that's it. That will be step 12. So finally we end up with this, a finished PCB with all the layers sandwiched in between. So obviously we have a bunch of other small steps like cleaning, inspections, going from this area to this area from the factory and so on, but those are not so important. I've tried to pass only through the most important passes that are like the drills, the tracks, the solder mask, the pastes, and so on. So yeah, we finally have our PCB. Obviously the final step is the inspection and the packaging, because in a factory usually you send this to a client, so then you have the packaging with the boxes and so on, and usually they wrap this into vacuum plastic. They send it to the user and that's it, to the client, and that's it. Actually, I've ordered this PCB in two colors. The green one, which is the most common color, and also they do it a lot faster, because since they have so much orders in green, it is a lot easier when you place an order to just get your small PCB and add it with other PCBs that usually are green. But if you order like black or special colors like pink, for example, you might have to wait like 2 or 3 more days till they have a bunch of PCBs and not use an entire plate of copper only for your PCB. But anyway, I've ordered it in black as well because I like this color and I want my Arduino, this is actually called Electronubino, I want it to be black. And actually, if you want the files for this PCB, I share them for free in the description. This is a special Arduino made board. Actually, you can't call it Arduino, it has to be Electronubino in this case. And has, for example, double rows for the pins. We have pins for an I2C screen. We have an input for a module for Type-C USB. We also have a potentiometer and an IR sensor for using a remote. We have the pins for an SPI radio transmitter. What more do we have? We also have a buzzer, LEDs, and a bunch of other stuff here that we could use and directly prototype on top of this board. So soon I will be assembling this and show it you how it works. Okay guys, so let's just make a final recap, and obviously I skip a bunch of steps for cleaning and inspections. These are only the main steps and also the steps that I was able to make, because there are a lot of steps, for example the using of chemical products, which I don't have here. I wasn't able to make that, and I will try to show that only in video format because I don't have that steps here. And obviously if you order not just a 2-layer PCB but a multiple layer PCB up to 14 layers with pcbway, the process will be a little bit different. I've told you that from step 3 to step 7 they have like 4 more steps for the lamination of the interior layers, which is kind of the same. They apply a mask, they take out the copper, they create the layers, they merge the layers using a copper deposition, and then they laminate them in between, make like a sandwich, and then they place that inside of the normal PCB. So basically you have the same as here, a layer here of copper, but also have the same sandwich in between the PCBs. So those processes will be a little bit different if you order a multi-layer PCB. And obviously the same processes will be a little bit different if you order a different finish, a different color, with solder mask, without solder mask, with the silk layer and without, and so on. So depending on the settings that you select, the processes might be different. But as a recap, we start with this will represent like the big board that will arrive at the factory, and they cut this to size. And once it's cut to size, this represents like the 800 by 800 PCB. And this will just be plain copper. They clean it, they inspect it, they also remove all the organic stuff and all the dust on top of it, and they place it into the factory. Then the first step I told you is to make the drills, otherwise you might damage the tracks. So they make all the holes on the PCB, but we have a problem, the holes are not conductive. So they make all that process with adding copper inside of the holes, and also making electroplating. They add copper inside of the vias and the pads. So now we have the holes with copper inside. So next we have to make the tracks, but for that they first fill the PCB with a resin that is sensible to UV light. They create the mask, they apply UV light, Then they remove all the resin that is not hardened, so you will end up with this, which is the same PCB as this one with the drills, but they also have like the tracks under the resin. Now they can place this inside of a acid bath. They dissolve the entire copper plate, but not the copper that is below the resin. So you end up with this, which is our circuit made out of copper, but I've told you this is quite fragile, so in order to withstand a lot more time, they apply the surface finish, which in this case is a combination of tin and lead. So now this won't oxidize and will last for more time, but it's still fragile because it's exposed to everything. So the next step is to add once again some resin. This is a solder mask resin. Once again, it's sensible to UV light. They create the mask of the solder paste, the solder mask. They add it, they cure the resin, and then they eliminate the resin that is not hardened. So you end up with this, the same PCB with the circuit below, a protection layer which is called solder mask. Once this is finished, the PCB is ready, but they add some extra stuff. For example, the silk layer, which is all this white stuff with the components and the values and all the shapes that you want. And then finally, they cut the PCB to size and they package it and they send it to the user, to the client. And that's how we get very professional and high quality PCBs. So guys, I hope that you now know how professional PCBs and high quality PCBs are made using pcbway, the services of pcbway. By the way, they sponsor all my videos, so thanks again to pcbway for making all these examples for you. And obviously, the technology in these factories has become more and more high-tech. I remember when I first started making electronics projects, just one PCB like this will cost you like 80 to 100 and something dollars, and now for 10 of these PCBs you only pay $5 or even less depending on the offer that you have. So yeah, that is quite useful for me because I can make PCBs over PCBs, each time improving my project. Anyway, remember, you can download the files for this PCB and order it at pcbway. If you want to make your own Electron Urbino, you have all the specs below in the description. And if you like this video and you have learned something new, consider giving me a like, maybe comment below, or even support me on Patreon. That being said, thanks again and keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it. And the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.